In this video, we are going to look at Unit 7, Lesson 8, which is about arcs and sectors. So we're going to analyze portions of circles. So by the end of this video, you will be able to find the length of the arc and the area of the sector created by this shaded region. So first thing you should do is take a look at page 194 in your book. And you're going to evaluate the answers to these problems mentally. So try not to write down any of your work or calculate using a calculator. See if you can come up with the answer just by looking at the problem and thinking about it. If you need a reminder of your circle formulas, they are on your purple sheet for this unit. So you can go ahead and grab that and look at it. Think about this, evaluate, and then come back to the video. All right, so we're just trying to evaluate these mentally, and this means you're probably going to keep it in terms of pi because you're not going to be multiplying pi in your head. So if we remember area formula for a circle, that's just going to be pi times the radius squared. So in this case, we would be doing 8 squared, which is 64. So the whole area here would be 64 pi, and I'm just going to write this down so that you can see it as I talk about it. But this would be the area of the whole circle. And then we have half of it. So we're only going to want half of 64 pi. So hopefully you came up with an answer of 32 pi. So a similar idea here, but now we're doing arc length. So we're going to be wanting a part of the circumference. So remember that circumference is 2 times pi times the radius. So we're going to be doing 2 times the radius. In this case, the radius is 8. So 2 times 8 is 16 pi for the whole circumference or the whole length around this. And we only want half of it. So half of 16 pi would be 8 pi. So a similar idea down here, the whole area would be 6 squared or 36 pi. Now this time we have 1/4 of it. So if I just think about dividing this by 4, that would be 9 pi. And I guess we could be thinking units squared for the area we should probably be doing. So then here we're going to be doing 2 times the radius, which is 12. And then times pi would be the entire circumference. And we only have 1/4 of that. So we're going to divide this by 4. So this would just be 3 pi units for the arc length. But so not having to fully calculate out by writing everything, but thinking of squaring the radius with a pi for the area. And then thinking about how much of the circle, only half of it. So dividing by 2 or 1/4 of it, dividing by 4, and similar idea for that circumference. So thinking about a new vocabulary term here that you maybe remember, maybe don't, is a sector of a circle. So a sector of a circle is just the region enclosed by 2 radii. So in this case, these are shaded. There's really 2 sectors here. You've got the shaded sector and the non-shaded sector. But just a portion of the circle enclosed by these 2 radii. And again, by 2 radii would mean this would not be considered a sector. So this is not a sector since those do not connect to the center of this circle. So this one would be a non-example. So sector has to connect to that center. All right, then on page 195, for each of these circles, find the area of the shaded sector, so that blue piece, and then find the length of the arc that outlines it. All units are in centimeters, and continue to give your answer in terms of pi like we just did for the warm-up. So go ahead and try these, and then come back to the video. So let's take a look at some different ways that you might have solved these. So if we think about kind of the total area for this one, again, we're going to square the radius, which is 100 pi would be the total area. So you could have thought of some different ways to calculate this. So in our warm-up, we had 1/4 of the area. This time we've got 3/4. So you could have thought of maybe dividing this by 4, which would be 25 pi per fourth. So this right here is 25 pi. We want the other part. So that sector area would be 75 pi. Maybe you thought of what 3/4 of 100 is. So 3/4 of $1 is 75 cents. So maybe you thought of doing 3/4 of 100 or doing 25, 25, 25. Okay, so 3 of those fourths to equal 75 pi that way. Then the circumference here, okay, so the whole circumference. So the full circumference would be 2 times the radius, which is 20, and then pi. And then again, we want 3/4 of this. So you could divide it by 4 to figure out that 1/4 is 5 pi. So for our arc length, which we use an L for, we want 3 of those fourths. So 3 of those would be 15 pi. Okay, maybe you did 3/4 as a decimal in your calculator, 0.75 or 75%, and used that to help you. But either way, arc length 75 pi, or sorry, sector area 75 pi units squared. Oh, centimeters in this case. They told us everything is in centimeters. So centimeters squared here and centimeters for the arc length. So then this next one, our area of this would be 12 squared, which is 144 pi, and then centimeters squared for that total area. So thinking about how many times do you feel like this slice would fit in? So maybe you said 360 divided into 60-degree chunks gives us 6 slices. Maybe you even kind of looked at doing this and you thought 60, 60, 60 would give you 180, and you could redo that down here. So you got 6 equal slices. So then you could take this area and divide it by 6, and that would get you your sector area. So 144 divided into 6 equal chunks gives us 24 pi centimeters squared for that sector area. And then a similar idea here for the circumference. So 2 times the radius is 24 with a pi. And then dividing that into 6 equal chunks. So divide this by 6. So the arc length would be 4 pi centimeters. So then this next one might not have been so easy to do as far as like thinking of the fraction of the circle. So this one, it was kind of easy to tell it's 3/4. This one wasn't so bad to figure out it would fit in there 6 times. But how many times is 135 going to fit in here? Okay, so 360 divided by 135 isn't a nice number. Okay, it's not a whole number, which means it doesn't fit in there an even amount of times. So we could do a couple of different things here, but if we think of the portion of the circle that we have, that's 135 out of 360 degrees. This would get us our fraction. And you could leave it like that, or you could simplify it down. So both of these divide by 5. So 135 divided by 5 is 27. 360 divided by 5 is 72. These divide further. They both divide by 9. 27 divided by 9 is 3. 72 divided by 9 is 8. So you end up with 3/8 of the circle. Okay. And so then we could take the total area. So our total area is 16 squared, which is 256 pi. And now we only want 3/8 of that. So you could do 3/8 times that area. And if you do 3 divided by 8 times 256, you end up with 96 pi centimeters squared for that area, for the sector area. And then circumference, remember we do 2 times the radius, which is 32, and then a pi. And now again, we want 3/8 of this. So we're going to do 3/8 of the total circumference, which is 32 pi. So if you multiply these together, so if you do 3/8 of 32, so 3 divided by 8 times 32, you end up with 12 pi centimeters. So that's one way you could have done it, by looking at the fraction there. You also could look at this fraction as a percent. So if we take and we do 3 divided by 8, that's 0.375 or 37.5% of the circle. And then you could have multiplied, I mean, which is kind of what you probably did in your calculator, but then multiplied that decimal times the 256, and that would get you the 96 pi as well. Okay, if we're looking at the sector area again. And then you could have done that times the circumference as well. Okay, so then done the 0.375 times the 32, and that would have gotten you that 12 pi centimeters for the arc length. So looking at the portion of the total area or the portion of the total circumference. So take a look at this image. How does this explain the area formula? So see if you can see it. So if the whole circle around is 2 pi r, because that's the circumference, okay, so if we just went part way around, okay, that would be pi r, and this would be the other pi. So then we'd get pi r for this part, okay, and pi r for this bottom part. So that's each of kind of half of the circumference. And then we've got the height there of each of these kind of triangles. So if you look at each of these triangles that they're putting, they're each r units tall. And they kind of interlock with each other there and create almost like a parallelogram. Okay, the smaller and smaller you make these little sectors, the more and more this side would be more like a segment, more like a straight line. So then if you think of doing the area of this parallelogram, it would be pi times r. Okay, so pi r times the height. So base, which is pi r, times the height r. So then r times r would be r squared. So that kind of gives you an approximation for the area of a circle. All right, then activity 8.3. So Mai says that she knows how to find the area of a sector or the length of an arc for central angles like 180 degrees or 90 degrees. So those were some that we looked at here, where we had, you know, a 180 degree central angle, so it covered kind of this whole space, or a 90 degree central angle where it covered a fourth of the circle. But she's not sure how to do it for central angles that make up more complicated fractions of circles like we just looked at for that 135. So let's take a look at first this circle here. So could you explain to her using just theta and the radius? Okay, so theta and r, show her or tell her how you would do it for any circle, and then actually apply that in number 2. So see if you can explain it in number 1 and try it in number 2, then come back to the video. All right, so if you remember when we were doing the sector area, so we wanted to come up with the portion of the total circle that we had. So when it was like 180 degrees, we know that's exactly half the circle. Okay, and that's because 180 divided by 360 equals 1/2 or 0.5. Or when this was 90, that's because 90 out of 360 is 1/4. So it doesn't matter if it's a complicated angle. What we're looking for is the portion, okay, or the angle that we have out of the total, which is always 360. So this will give us our portion of the circle. And then if we're trying to find sector area, we have part of the total area of the circle. So how do we find area of the circle, or the total area is pi times the radius squared. So we're looking for the fraction of the circle we have. So how many degrees out of 360 do we have times the total area? Or when we're doing, and let me put this in blue for sector area, or when we're doing arc length, okay, so when we're looking for just this arc length, then we still want to be looking at the portion of the whole circle. So how many degrees out of 360 do we have? And then this time we're looking for a portion of the total circumference. And the total circumference is 2 times pi times the radius. So we'd figure out the portion we have and times it by the circumference. So in this problem down here, then we'd be looking at the portion of the circle that we have is 160 out of 360. And then you could certainly simplify that if you wanted to. If you're trying to keep it in terms of pi, you might want the fraction to be reduced. Okay, so we could just cancel out those zeros by dividing by 10. Then both of these divide by 4. So 16 divided by 4 is 4. 36 divided by 4 is 9. So we have 4/9 of the circle. So if we're looking for the sector area, then we want to put the total area in here. Okay, and area is pi times the radius squared. So the radius squared is 25 with a pi. So we'll multiply these together. And if you want to keep it in terms of pi, then we would multiply these fractions. So 4 times 25 is 100. 9 times 1 is 9. So we have 100 over 9 pi inches squared. And you could certainly use a calculator to come up with that decimal as well. Then when we're going to do the arc length, we still have 4/9 of the circle. But this time we have 4/9 of the circumference, not the area, if all we're doing is looking for this arc. So then we would be doing 2 times the radius, which is 10 times pi. So doing 2 times the radius and times pi. And then you could multiply these fractions again. 4 times 10 is 40. 9 times 1 is 9, and then pi. And that doesn't reduce. And then we have inches. So again, you could type that in your calculator, but this would be your arc length. And this would be your sector area. All right, so compare and contrast the process of finding the area of the sector and calculating the arc length. So you need, in both, you need a portion, okay, the portion that you have times the total. But so the portion will stay the same, okay? This is where you take the central angle out of 360, but then what you're multiplying it by changes. So if you're looking for, the total, the sector area, then you're multiplying this by the total area, pi r squared. Or if you're looking for the arc length, you're multiplying this by the total circumference, which is 2 pi r. So arc length is a portion of the circumference. Sector area is a portion of the area. So take the fraction you have times whichever you're looking for, total area or circumference. Okay, so where might you see some of this stuff in real life? Probably the most basic is pie and pizza. So looking at your pizza, okay, how much pizza you're eating in a couple of slices, the arc length being the crust. Okay, maybe you're looking at a swimming pool, a circular swimming pool, a hot tub. Okay, looking for the kind of foam around the hot tub versus the space that it takes up, or different chunks of that. You can put this on your reference chart. So again, first find the fraction of the circle that you have by doing the central angle divided by 360. And if you need to kind of remind yourself of that. You could write that in as well. And then you multiply by either the area or the circumference, depending on what you're trying to find. So if you're looking for sector area, multiply by the area of the circle. If you're looking for the circumference, multiply by the circumference. Or sorry, if you're looking for the arc length, multiply by the circumference. So then here is the summary. A sector is just a region enclosed by 2 radii. You can divide the central angle by 360 to figure out what fraction of the circle is being represented. Then multiply this by the total area if you're looking for the sector area. So down here, you'll see I kind of highlighted the area stuff in orange. So they figured out the total area by doing 12 squared pi. Okay, then multiplied that by the fraction of the circle they have, 225 over 360, which simplifies to 5/8. Multiplied that by 144 pi to get the 90 pi. And then a similar process to get the arc length. Okay, so they took 5/8 times 24 pi for the arc length. That gave them that 15 pi. And then they did the 5/8 times the 144 pi, which is the area, to get that 90 pi. All right, so hopefully now you can do the cool down so you can find the area of this shaded sector and then also the length of the arc created by that shaded sector. If you have any questions, be sure you reach out to your teacher to ask for help.